As we said earlier, it can be difficult to read exact coordinates, especially if they are not integers from the graph. So using algebraic method would be a good idea to solve the system of equations. One such method is called substitution method. Substitution method. We're going to take a look at substitution method now. Let's take a look. Solving by substitution method. We have two equations and two unknown. Since the second equation, equation number 2, is solved for x is equal to 2 minus y, we can substitute 2 minus y for each x in the first equation. That's why they call it substitution method. We take the first equation, we substitute for each x 2 minus y, and then this forces us to have only one equation and one unknown, which is y. We just solve for y would be equal to 2 in this case, and we get this solution, and we can substitute that back into either of these two equations. Probably the best equation to substitute would be the one that is solved for x. You have x equal to 2 minus y, you substitute for each y 2, so x would be equal to 0. So this would be the solution set is 0 and 2. This is how they write the solution. This is where these 2 points intersect. Now if this second equation was not solved for x, we could easily make that steps ourselves. Solve x in terms of y, or we could solve y in terms of x and substitute for each y's corresponding value in terms of x. We would get the same exact answer. So this is a summary of the steps. Solve one of the equations for either variables. If one of the equations has a variable terms with the coefficient of 1 or minus 1, choose it, because the substitution method is usually easier. So you want to look for the variable with the coefficient of x or y equal to 1, so we can simply solve that variable in terms of the other one. And then step number 2, as we did, is substitute for that variable in the other equation. The result should be an equation with just one variable, as you saw. And the step number 3 to solve the equation from step number 2, and then you find the other value. You substitute the result from step number 3 into the equation from the step number 1 to find the value of the other variable, and then you want to check the answer at the end. Make sure the answer that you claim it's the solution works for both equations. Let's take a look at this example. Solve a system by substitution. Here we have two equations and two unknown, and I look at here and see the first equation, number 1, I see the coefficient of 1 for y. So I can simply solve for y here. Solve equation 1 for y. So all I have to do is just subtract 4x from both sides of the equation here. So I would get y is equal to 5 minus 4x, and I would substitute this into the other equation. So everywhere I see y, I would substitute 5 minus 4x. So now I have one equation and one unknown in terms of one variable x. We can easily solve that. X would be equal to 2. Once I find x equal to 2, I would substitute that back into either of these two equations. The one in red probably would be the best one to choose. If I substitute for each x2, then I can solve for y. So you would substitute for each x2, you would find y is equal to minus 3, and then you check your answer. Make sure the answer would work for both of them.